Okay, so welcome to the July 27th meeting for Project Antrea. We have a pretty packed and interesting agenda tonight. First, I think Jake is going to present to us a tool he's been working on called NCTL Query. So it's an extension to the NCTL command line tool. And I think after that, we are going to discuss, let me see, we're going to have an update on Antrea specific metrics for Antrea specific network policy metrics by Chan, who's been working on this feature. Then we're going to discuss the performance for Antrea proxy when it comes to cluster IP service load balancing. And I think the last topic we are going to discuss is whether we think it's a good idea to enable Antrea proxy by default on Linux, starting with version 0.9. And yeah, I think that's it. So the first topic on the agenda is Jake, who's going to be talking about NCTL query. Jake is a student at Brown University in computer science. And this summer, he spent some time working on Project Antrea. And he's going to show what he's been working on, and he's preparing a pull request for this feature. So Jake, you can go.
Hello, everyone. It's nice to make your acquaintance. Yeah, so as Antonio was saying, I'm an intern this summer. I've been working on Antrea, building NCTL query, which is an extension to the NCTL tool. I actually have a really nice demo that I prepared for the poster presentation. For those of you who are interested in like the intern poster presentation, that'll be on the 30th. And I could send you some information for that. Anyways, just give me one moment and I can pull up the video. Also, if the video doesn't really work when I'm sharing my screen, I have a OneDrive version, so I could share that with you guys, but just let me know if there's any problems with audio or anything like that. Hello, my name is Jake Sokol, and I'm an intern this summer working on Project Antrea. So it's Project Antrea, and how are we trying to contribute to the ecosystem of VMware Project? Project Antrea is a solution to Kubernetes networking needs. Kubernetes are these collection of pods, and you would like these pods to network with each other. However, Kubernetes. Of course, this is like a very condensed version for the 3-minute presentation for the poster session. I have a much longer demonstration of the tool actually being in use that you'll be able to see. So just keep that in mind as you watch the video.
Okay. Hey, the audio is a little choppy, but I can make it out. But does it sound perfect to you, or is it also choppy to you?
No, you're right. Jake, I thought you had some slides that you could show and you could talk over them. I think it would be better than just playing the video.
Sure thing.
And you can play the video of the demo you want to show, but then cut the audio and talk over the video. It would be better.
Yeah, that sounds good. All right, so this was my poster for the presentation, in the intern section. You guys all know about Kubernetes and how network policies apply to Antrea, so I could skip over that for now and instead talk about the problem that we're trying to solve with NCTL query. So as you scale clusters to very large sizes and you have perhaps hundreds of network policies applied to hundreds of pods, you develop like a very complex networking structure with a very complex set of rules. And to put that in perspective, say you would like to investigate the network policies which are being applied to one certain endpoint, perhaps for like a security diagnosis or really for any reason. Um, well, every network policy has the ability to select the endpoint. And for each network policy, there is sort of a list of selectors which have the ability to select that endpoint either as an applied, as the network policy could apply to the endpoint, or it could reference it in egress or ingress rule. So you could see that if you have a very large amount of network policies, then to actually examine which network policies are relevant to a certain endpoint, you have to iterate through the entire list of network policies. And as a user of Antrea, that could be a burden. So our solution is rather simple, and it draws inspiration from some of the other relevant networking plugins for Kubernetes. And as we've been discussing, the solution is AntCTL query. And sort of the idea of AntCTL query is that it's a more sophisticated tool to track relevant resources. So for the one particular case we're interested in is being able to track the relevant network policies to network endpoints. For the first iteration of design, a network endpoint is simply a pod in a namespace. So the way it works, you could see from this sample output what the what the results of a simple endpoint query are, and I'll show you the whole demonstration of the tool shortly after I go over this. Given a pod and a namespace, you are able to see the policies which apply to that endpoint and those which reference the endpoint in an egress or an ingress rule. Yeah, so I'll show you, hopefully the audio isn't as choppy as it was before. So now I'll show you the actual demonstration of the tool, which I was able to show in the poster session, and then I could go over the steps.
Jake, the best thing to do, I think, is to cut the audio for the video, and then you can pause when you need to and talk about what you're doing. I think.
Oh, that's really, yeah, that's a good idea. Okay.
The other thing you might try is cut your camera in Zoom because it sucks up bandwidth coming out of wherever you are. And you don't really need it if you're showing the video instead.
Yeah, that makes sense. All right. Okay, so here we have a pretty simple setup. Sorry, is my video blocking your view here? Oh yeah, I'll move that in a second. And I have this network policy, which I've already went ahead. Okay, so we have a pretty simple setup here. We have a single service running, just a regular Nginx server, and we have a network policy, which you'll see in a second, I've already applied to the cluster. Yeah, so the important thing to note is that this is the labels where access is set to true when specifying an ingress rule, and the pod selector selects apps set to Nginx. And I'll just go ahead and tell you that this Nginx has that label, app Nginx. All right. All right, so the audio or the visuals cutting out a little bit there, but what I'm doing is I'm creating a BusyBox container running with access set to false. And what we're going to do is we're going to see the results of AntCTL query endpoint for both the Nginx server and for BusyBox with the access label set to false. See that it has access Nginx. Okay, and so this is
Jake, can you stop the sound in the video? It's right there. Just click on the. Just remove the sound, otherwise we keep hearing it.
Okay.
Yeah,
oh, that's
and then
okay.
you can just play the video now and pause when you need to.
All right. Yeah. Okay, so this is sample output. We did change this a little bit with some of the spacing, but this is the sort of the general idea of the output we'll have for query endpoint. We could see that the applied policies of Nginx, it's being selected by access Nginx, and the three like pieces, I guess, of like reference data are name, namespace, and the UID of the resource. Okay, and now we see the result of when we query BusyBox, because the access label is set to false, we get no applied policies, no egress and ingress rules which contain policies which reference BusyBox. So now what I'm going to do is create a new BusyBox. You'll see with access set to true, so that the network policy should select it in the ingress rule. We're going to check that it exists, and it does. And I should be querying it now. Yeah. And yeah, okay. And we see here that now we have BusyBox specified in the ingress rule. And this is useful because now we could see the return structure for ingress rules. Yeah, so one important differing field is this index field, and it basically helps the user see which rule of the network policy actually selects BusyBox. And since there's only a single rule and it's in the 0th index, index is set to 0. Yeah, and so that sort of wraps up a brief demo. I'll be sending in a longer demo to Antrea shortly. Yeah, so going on from there, I talk about future work. So some future work that we're considering is providing support for querying network policies, and you could sort of see that as working like in the reverse direction. And more abstract. Here, let me exit out this video real quick. And having more general selection, a more general selection mechanism, so that instead of having to just do like a pod and a namespace, you have the ability to say like return a list of endpoints. We also have some more ambitious visions that I think might be cool, like using this just as like a general policy filtering mechanism for other sorts of visualization. Yeah, so that's how the tool works. Now I could, Anton, do you think it'd be a good idea to dive into the implementation now? Or could that just be something that is reviewed?
Oh, we'll let people review that when you open your pull request. I think
Okay.
it should like take 5 minutes for questions.
Okay.
So I'm not sure I understand that correctly, but basically we support to query the policy let me see how to say that. to query the policy that reference the source port or destination port question.
Are you asking about querying network policies as opposed to querying endpoints?
Or endpoint that may need to return all the policies reference this endpoint, no matter it's from or to or apply to.
Oh, okay. Yeah. So what do I mean? So you're asking what I mean when I say a network policy references an endpoint?
Yeah, I'm trying to understand what is command.
Okay. Yeah, that's a good question. Yeah. So Kubernetes network policy is able to reference endpoints in three different places.
I see.
The first is just like actually I could actually pull up the here. Let me pull up the demo network policy so I could compare that to the result that I showed you. Okay. Let me share my screen. Right. So you could see that like any network policy is able to reference endpoint in three different places. The first is in the actual pod selector, like which pods does this policy actually apply to, and that's determined by the labels in the pod selector. And then you could reference an endpoint as an ingress rule, which specifies like communication from some pod, and an egress rule, which is the opposite to some pod. So that's like the different. So that's what I mean by a network policy is able to reference an endpoint, if that makes sense.
Okay, got it. Yeah, I'm asking because in the undercut, the kind of undercut, we already have a command to return the policy applied to a port. So probably I think what you add is for 4 and 2 referencing 4 and 2 from and 2. Right? So could I ask in the implementation how you do the resolving of the reference? It's like you acquire some state from the controller, or you
right.
compute from labels by undercutting.
Yeah, so you guys will be able to see my full implementation as soon as I open up the PR. But from a high level, what we do is we add a new indexer to the applied to group store and the addressed group store. And
but at a high level, yeah, Jianjun, what you said is correct. NCTL connects to the controller, and then we use the state from the controller to resolve the query.
Okay, got it.
So we added an indexer so we can quickly look up, given a pod namespace and name, we can quickly look up which applied to group and address group that pod is in. And then based on those groups, we just link back to the network policies.
Okay, got it.
And it gives you the full list of network policies, not just the one that takes precedence at the moment.
Okay.
So I know this is in ant control, so given that it's only usable with Antrea, but at the back end of this, how much of this might be portable to other CNIs or Kubernetes in general, based on the way it's designed?
well, the thing is, I don't think it's usable by other CNIs for the reason that we're using internal Antrea references.
But I think, Steve, that's a great question, because one could just like write a tool which would just like connect to the Kubernetes API server and look up like the full list of network policies, and then do some computation and kind of like answer those queries, right? But that would have required a kind of like replicating a lot of the logic that we already have written in the Antrea controller in a way.
Yeah, I'm just trying to think how you would do that to get performance. You'd almost have to draw everything out, maybe keep it in, I don't know, an in-memory database for performance.
Yeah,
It
basically.
might
And
not be pretty, but it,
yeah, and in the case of Antrea, that kind of stuff already existed, right? So
right.
we can quickly do those lookups. And I think another thing that we didn't mention is we kind of like want the tool to also work with the Antrea specific network policies, like for different personas, right? So cluster network policy and the Antrea specific namespace network policy. So yeah, the tool is going to work with those as well.
I'd suggest maybe when you submit this PR, I assume it's going to come along with some documentation, and maybe put that in the design documentation to explain it to others that follow, because I can picture somebody going out there to evaluate Antrea versus other CNIs saying, oh, I see this feature in there that would be valuable. I wonder if it's in all the other CNIs too. But when you go through the backing description of your design and the reasoning that went into your decisions, it would become apparent to the evaluator that, hey, this is Antrea specific. And they're likely to have that question in the back of their mind. So maybe answer it in the design docs, documentation, or both.
Yeah, sounds good.
Yeah.
Yeah, I'm just thinking if we really want, we can do a light policy analyzer by controller code and undercut. But we don't install agent and Kubernetes CNI plugin. But we just run the controller and then run your undercut tool to analyze the provide light policy if you want.
Yeah, I mean, in a way, we do leverage what's already in the Antrea controller. But if you were to build it from scratch, kind of like just for as a generic mechanism for Kubernetes, just supporting Kubernetes network policies, and you would build those like maps from scratch, I think the logic would end up being simpler than what we have in the controller, right? But
yes,
yeah.
But what I mean that you can, if we want, we can make a analyzer mode for the controller.
No, yeah. No, yeah.
Sure. One more comment here. I'm not sure you already did some testing on this. Maybe better to check the overhead added to the controller if we add new indexer.
I asked Jake to do that, and he has some numbers, and he'll share them. Have you shared them in the issue, Jake, or not yet?
Yeah, I believe I added several graphs because memory was like a concern for us, so we made sure to reflect that in the testing.
Yeah, so some exact numbers are in the issue on GitHub that Jake opened, but I think the memory footprint was like around like I think it was about 10%, 20% overhead from the extra indexer that we're building.
Okay.
Hey,
okay.
Jake.
Go ahead.
I'm sorry. Just one last question. So I think I overheard that when you deployed all those pods, the Nginx pod that you were deploying at the very beginning also had the access equals to true label. I don't know if I hear that wrong or, but you know, on the get endpoint on the Nginx pod, on the ingress rule, I don't actually see the pod itself because it's, you know, selecting ingress from the label. From my understanding, it should be also selecting itself. Did you explicitly, you know, remove itself from the address group, or is it something else?
So are you asking me if access is set to true for the Nginx deployment?
Yeah.
I don't believe it is.
Oh, okay. Maybe I heard it wrong. So that makes sense. Okay, cool. Thanks.
Okay.
I have a question. Can this be extended to IP blocks as well?
Actually, yeah, I think I still have to discuss this with Antonin, but we have that on the roadmap for future work. So hopefully I'll be able to get to that by the end of my internship.
Okay.
Okay, thanks everyone. Thanks Jake for attending. I know it's late your time, and thanks for the presentation. We're gonna move to the next topic on the agenda because we're a bit running out of time here, and it was an update regarding cluster network policy metrics by Chan. So Chan, if you're ready.
Sure. Thanks, Anthony. Can you see my screen?
Yes, we can.
Okay. I just created this issue last night and put all the design details here. And actually, it has been a little different compared with the previous version. That the matrix data, I assume it will not be persisted to the Kubernetes CRD because of the performance effect. But I can talk about the details later. And overall, the proposal is to collect and expose the statistic data of network policy. And when working on this, I'm thinking maybe not only for Antrea specific network policy, we could also do that for Kubernetes network policy because they follow the same model, and they just have a little difference when enforcing them. And if we don't write this metrics to Antrea specific network policy CRD, then they could share the same metrics API to access the metrics. So it should be good to have it for Kubernetes network policy too. And the policy, the metrics API will be exposed by Antrea controller, and the Antrea controller is responsible for collecting the metrics from all Antrea agent and serve it through its metrics API. Then the monitoring solutions and the users can access this data via the Antrea controller metrics API. And also it could be accessed by Antcato get metrics network policy, making it easy to view. And if we want to do this, if we want to have Antcato to access it, the service must be registered to the Kubernetes aggregated as an API service. So even Kubcato can access this data. I could talk about it later. So, and the metrics data includes total number of packets, bytes, sessions of a given network policy. Since the metrics is collected asynchronously and periodically, the data got from the metrics API is not real time and may have a delay up to the collection interval. I'm thinking about 1 minute by default. For detailed design, for the scalability consideration, I'm assuming we want to support 100,000 network policies and 1,000 nodes, and assuming each node will get 1,000 network policy applied. So if the metrics data is collected every minute, it means that each agent will report 1,000 metrics per minute, and the Antrea controller will have to sum up 1 million metrics for 100,000 individual network policies per minute. So this sounds no performance issue when collecting and aggregating the data in above scale. But for storage, assuming we want to persist the data to Kubernetes CRD, then we have to perform 100,000 API writing per minute. It means more than 1,000 API writing per second by average. And even we consider make the interval to up to 10 minutes. It could mean more than 100 API writing per second. So I think it's not reasonable to write this state to persist this state to Kubernetes CRD. And actually, the only difference that we persist it in CRD or we solve this API while Antrea controller is there is no difference from user perspective because they all get this data from API. The only difference is that the data will be lost or not, because if we persist it in CRD, then after Antrea controller restarts, we can reload this state and keep counting. But if we don't persist it, the data will be lost after controller restarts. But I assume that if user or some other monitoring solutions want to persist this data, they could do it by themselves. And so in this proposal, I am thinking just storing the date in memory. And if the controller is restarted, all the metrics will be reset to 0. And for metrics collection by agent, Antrea agent is responsible for collecting metrics from open flow stats. And in current network policy implementation, each network policy rule gets an unique conjunction ID, and each flow has two stats, the packets and the bytes. But the current flow stats only counts the first packet of each session, as we can see in the conjunction match flow, we only match the one direction of the session. It always come from it has always the sender. It always matches the sender's address as the source address and the destination, the receiver address as the destination address. So the following packets were not hit by this rule. So and were hit by a generic rule match the established packets, the packets of established sessions. So one possible solution we have considered is to use CT network source and track CT network destination, CT transport destination as the condition of the conjunction match flow. Like this, this could solve the above problem. That so because this CT network source field means it will not match the source address of the packet, but the connect track source address of the session. So even for the reply packets, it will hit by this rule. But we also see some drawbacks in this solution. First, the CT network source address requires OpenWay Switch 2.8. I think some distros don't have it yet. And the second is in ingress table. In ingress table, we are not using destination address as a condition, but the off port. So it is impossible for, if we want to continue using the off port, it is impossible to leverage the CT network source or CT network destination. And the third one is raised by Srika. I think he mentioned that currently we only need to match each packet, each session once, because the following packets can just hit the generic flow. But if we change the flow in this way, the first packet of the reply packets will also have to go through the pipeline and match the conjunction condition flows. So, but the overhead should be minor. So, but it still adds some overhead. So I had a discussion with Wayne, and she proposed to persist the conjunction ID to connect track label and have dedicated matrix collection flows to match the connect track label. The flow will be like this. In this way, we don't need to change the original network policy flows a lot. We just need to resubmit the packets to another matrix collection table. And another change is that we need to load this conjunction ID to the connect track label. Then in the matrix collection table, we could use the connection label as a match field, and we can then use city state new or not new as another condition to collect to distinguish the first packet of a session and the following packets, and the stats for the new state will be considered as the session count, and the sum of them will be considered as the packets count, and the sum of the bytes will be considered as the bytes count. And after entry agent collects the matrix, it needs to report the data to entry controller to aggregate. We have two collection model. One is we considered two models. One is entry controller access entry agent API. This is how Kubernetes metrics server works. Basically, the Kubernetes metrics server collects the pod and the node metrics from each kubelet, while the kubelet summary API. But the problem we have is that it is difficult to enable server authentication for agent API. We don't have it for now, though entry agent has its own API, but it is only used for the Prometheus API and the support bundle for now, and we are still considering removing support bundle from this API and change to another mode, because it is really difficult to address the certification generation and distribution for each agent, the problem of the certification. And so in this proposal, instead of controller pulling data from agent, I propose to let entry agent push matrix state to API of entry controller, similar to the current way that entry agent pulls the internal network policy from entry controller API. And so in this way, the same authentication authorization mechanism and even the TCP connection for the internal network policy API can be reused. And another consideration is each entry agent could restart, and it will restore all network policy stats, all network policy open flow. So the open flow stats will be reset after that. So if entry agent sends the whole stats to entry controller and they are asynchronous, so it is very hard for entry controller to aggregate the whole stats, given that each agent could restart itself and reset its state individually. And so in this proposal, I want make entry agent to calculate the incremental stats and only report the incremental stats to Antrea controller. So the controller can, oh, sorry, this is a typo. The Antrea controller could simply sum the data up, and don't need to consider the agent restart case. And for the API design, there are two new APIs. One is for the metrics collection from agent. So if we want to support all three kinds of network policies, because the network policy could have the same name and the namespace, so they could conflict with each other. So I add a type field here to distinguish from them. And the state includes packets, bytes, and sessions. And the API endpoints doesn't need to follow the Kubernetes API pattern. And we cannot follow it because we want to push the stats in batch, not by individual item. Otherwise, it will be API overhead. So the mesh agent will report the a batch of network policy stats every minute via this API. Then Antrea controller will collect will get this state and then sum them up and aggregate them, then store them in cache in memory. And there is another group of API. I'm calling them metrics API for now. This API will follow the Kubernetes API pattern. It could support list and get web. So, and we could also register it as an Kubernetes API service. So it could be accessed by the Kubernetes API. We could also access it via kubectl get. We could also implement our own command to get the detail of the metrics, because the kubectl get cannot have the value of the resource if it's an API service. And so the API group, for now, I name it metrics Antrea Tanzu welcome, and the endpoint will be like this. And I still have an open question that should we have separate API endpoint for Kubernetes network policy, cluster network policy, and Antrea network policies? The reason is if we just use one endpoint, then there is difficult to have RBAC for this resource. But you know, the cluster network policy is cluster scoped. I'm not sure that if we want to limit this metrics only accessed by cluster admin. So this is a question we could discuss. And after having this, user can access the network policy metrics with this metrics API, and they can also use Antrea to get the metrics, and by specify a network policy name and a namespace, or or not specify a name to get the list of metrics. And that's all for the detailed design. Any question?
The chain, so if there's no change on the agent side, we don't really need to report the stats for one policy.
But it still needs to calculate the increment data, right? So we could remove the zero value from the summary date. Yeah, it could have that.
Okay.
Chen, I have a very high level question. I don't know if it's valid though. Is that when I look at this, I feel like your design is to basically have the statics being sort of stateless when published to the API channel between the client, the agent, and the controller. So I see on the agent side when we watch for address groups and apply to groups, for example, we sort of tend to disconnect and reconnect and everything. If the matrix you publish to the API server is sort of like stated, how would you guarantee the increments are sort of like added correctly, meaning we don't like miss any increments or double count any increments?
This is though this is not a long connection, though the underlying TCP connection is a long connection. The HTTP connection is short. It just report the date 1 minute per minute and disconnect the HTTP connection. So I assume that as long as the data is pushed successfully, the data is we could consider that we have the agent can refresh its cache and use the latest value as the base of the next round. Does it make sense to you? Because this is a HTTP post request. It is not a stream connection.
Okay, I see. I think it makes a little bit more sense. But when I consider is this, when I also want to consider the cases where agent, I don't know, tend to restart. So if that's the case, a new fresh agent will install new flows for the network policies, whereas the old flows will sort of just hanging there, right? And the new agent will not be able to will now basically look into these old flows. And in fact, these old flows might still be, having traffic hits and whatnot in the agent downtime. So I'm thinking, those will be the things that we definitely gonna miss if we have, a stateless.
I understand the situation. Yeah. There are two cases. One is the only entry agent is restarted, so the flow is persistent. Another is both of them are restarted, so the stats are reset, right? So for the first case, I'm considering that when the agent comes up, it should have a snapshot of the current stats and use it as the base of the incremental date. And after a period like 1 minute, it should collect it another time and calculate the incremental part and report the incremental part only. So if the data between it is off and it is on, the matrix, the stats between that time window will be lost. We don't have a good way to distinguish whether we have reported it or not before, right? So for another case, it is actually it's the same, because the snapshot will have all zero value for all narrow policies, and when it collects the matrix the second time, it could calculate the incremental part. I don't have a good way to collect the stats when the entry agent is off. If you have a good idea, you could raise it. Yeah.
Okay, yeah, I think that makes sense. Thanks.
All right, Chan, thanks for the presentation. Please comment
Okay.
on the issue if you have any follow-up questions.
Okay.
So I see
Thank
that
you.
we have 10 minutes 10 minutes left, sorry, so we may not be able to go to the end of the agenda. But the next item is to discuss the performance evaluation of the Antrea proxy. And I think that's Chan again.
Okay. Thank you, Anthony. I did some performance test in my private test bed. It's KVM based, and I don't think the absolute value is reliable, but we can tell the difference between the two modes. One is when we use kube-proxy to proxy the access to service, and another one is we have OpenFlow to proxy the service access. And I have two tables. One is for the intranode case. As you can see from the pictures, that the TCP stream, if it's the kube-proxy case, compared with the port-to-port and port-to-service, it will decrease a lot. I think it is because in this mode, we have to route the traffic to the host network namespace once, and then the packet will have to go to the IP tables rules in the host network, and also look up the root tables of host network, then get back into the OS pipeline, and then again go through the OS pipeline open flows. So it decreases a lot. And in the Antrea proxy case, the throughput is almost the same as port-to-port. So this is expected. And when I add a lot of service, background service to that kube-proxy and Antrea proxy to creating a lot of IP tables rules and open flow rules, the effect, the influence on the performance is also obvious. Like for kube-proxy case, we can see that along with the increase of the service number, the throughput will decrease little, but for Antrea proxy case, the throughput is consistent regardless the number of the proxy, the number of network policies, services. And another metrics is the TCP CRR. This means short connection of TCP case. In this case, it will repeatedly connect and request, then accept, then get the response, then destroy the connection and create another new connection. So it's for the short connection case. And when kube-proxy is used, we can see that the performance decreases obviously when the number of service increase. And for Antrea proxy case, it is consistent. I think this is because, by the way, when I'm talking about kube-proxy, I mean the IP tables mode of kube-proxy. I think the performance gap is because for IP tables, it have to do linear search of IP tables rules to select the correct DNet destination. And for OpenFlow DNet, it only need to do some tuple space search, and it's based on hashi, so the performance is consistent. And for TCP RR, this is a case is a long connection, but it's a request response mode. So since it's a long connection, actually this performance is not affected by so the number of service, even for kubeproxy, because only the first packet will go through the iptables rules, and the following packets could just hit the counter track. So this is for intra-node case, and another is the inter-node case. I didn't see considerable difference between these two modes. I think it is mainly because that for inter-node case, the main bottleneck is not in the iptables or OpenFlow match. It's in the in-cap or decap. So both of them has similar performance in the different scenarios. So the for the kubeproxy case, the performance is slightly decreased when for the TCP CRR, as we can see. So this is the test result for the Antrea proxy compared with the kubeproxy. That's all. Any question?
Thanks, Chan. So we are not aware of any scenario where Antrea proxy would perform worse than kubeproxy with iptables.
Sorry?
So do you think there is any scenario for which Antrea proxy would not perform better than kubeproxy with iptables?
I didn't think of one. But recently we are comparing that with for zeros, but that is different from this case. That is for performance gap between Antrea with other CNIs. Yeah, but for kubeproxy and Antrea proxy, I think there is no scenario that kubeproxy, the way we integrate with the kubeproxy will perform better than the way we have OpenFlow for service access. Yeah.
Okay, but I expect the gap between the two would be smaller with IPVS maybe?
Yes, I guess that IPVS will have consistent performance regardless of the service number based on its technical theory, but I didn't test it. I can have a test on that too in future. Yeah.
Hey, Sean, with OVS offload, will internode numbers be better, right? The NCAP and DCAP?
Node number?
Will the internode numbers with OVS offload? The bottleneck will still be the NCAP and DCAP? Or
yes.
Will it change?
Yes.
Okay. So there will be some difference.
Yeah.
Okay.
Okay.
Maybe we could test it in while the no in-cap test bed, because we could remove the bottleneck of in-cap and decap too. Yeah, that's a good idea.
Okay. Yeah. Okay. Like with OVS offload, what will be the expectation? I mean, I did not get, like, is there any expectation of Antrea proxy doing better? Or?
Yeah. I would expect that Antrea proxy will do better than queue proxy in that case too. Yeah.
Okay, thanks again, Chen, for the presentation. We're out of time. The one item we didn't have time to cover on the agenda was discussing whether the Antrea proxy implementation should be the default, starting with the next Antrea release. I think that's an important topic, so either we can go over time a bit, or we can punt a discussion to GitHub and Slack.
I think we are doing some tests around Antrea cookie proxy implementation. So probably let's do offline and wait for some results from tests.
Yeah, so basically, if anyone has deployed Antrea with the proxy feature at scale, I think we would appreciate that feedback. And if anyone runs into any issues that we should take into account when making the decision of enabling Antrea proxy by default, that's also something we would like to hear about, so we can make that decision. So yeah, so please share any feedback when you use Antrea proxy. And I believe this is the end of the meeting now. So thanks everyone for joining. I'm going to just wait 30 more seconds in case anyone else has something they want to bring up. Okay, well, thanks everyone. Thanks for joining. Thanks Jake and Chan for presenting today, and enjoy the rest of the day or the beginning of your night.
Bye.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye guys.